Hello everyone, today we're going to be doing number 1 from the 2003 FRQ. So what's given to us is that R is the shaded region bounded by the two functions y equals root x and y equals e to the negative 3x, and that there's a vertical line x equals 1. A neat trick with these problems in general where you have to find area between two regions is that, if you can see from the answer key, the way they grade this is that you only need to know an integrand and an answer. That applies to all parts, A, B, and C. So my strategy with doing these problems is all you have to know is how to set up the equation. Because it's calculator section, you can plug it into your calculator and that'll get you your answer. So from this diagram we know that we're not sure which function is which. So the way I did it is I plugged in my calculator the two functions, so y equals, and then you can plug in first function, y equals root x, press graph, and we can see that y equals root x is the one with the positive slope. That means e to the negative 3x is the one with negative slope. So from here I wrote down which function is which, so we know that. And as you can call, let's do part A, find the area of the shaded region R. So from note 6.1 we know that how to do this. There's an equation and it's need the two intersections A and B, and its top function f of x minus g of x bottom function. So and then you take the absolute value of that gets you your area. So we almost have all the information so far, but we need this intersection. So the way you can do it is setting the two functions equal to each other, solving for x. The way I did it, because it's calculator section, I found it faster just to plug it, or just to use my calculator. So the way you find an intersection on these is you go to second calc 5 for intersection. You want to select one function, point of the other function that's above the other function, another point, it's on the opposite side, and then from there you can see that the intersection is 0.2387. Went ahead and wrote that down for future reference. So we have all the information we need to solve for part A. So here it's B, 1, we just solved for 2.387, that's the second intersection, top function, root x minus e to the negative 3x, take the absolute value of that. The way you find solve for integrals in your calculator, you go to alpha, window, 4 for f int, find integers, plug in b, so 1, and then the other intersection 0.387. You want to plug in this to your calculator, so, or not this, this. So root x minus e to negative 3x, top minus bottom function. So go ahead and do that. Yeah. And if you press enter, you'll get that the answer is 0.443, and remember to round to 3 decimal places. That's what they look for in these equations. Alright, so part B asks you find the volume of the solid generated about the horizontal line y equals 1. So from the notes, section 6.2, you know how to, the way to find this is pi times the outer radius squared minus pi times inner radius squared. I set this up the same way, using integral, so pi on the outside, your b and your a. And because you have to rotate this around vertical line y equals 1, you have to include a 1 right here and subtract this function squared minus the other function. Remember to do the same thing with this function as well. I plugged it into my calculator the same way I showed you before with integrals, and you should get 0.43. That's without the pi, but you can include that in. Later you can multiply out the pi, and remember to round to 3 decimal places. So this will work if you just don't decide to round the rounded answer. So just a reminder, the way they grade this, so you just need this, the integrand, the setup, and any one of these 3 answers will work. So in C, it asks you to find the volume, but in this case R is the base of a solid, and there's cross sections perpendicular to the x-axis where the height is 5 times the length of the base. Alright, so length, or the base, we figured out from part A is just top minus bottom function. The height, they just told us, is 5 times this, so the length. I set up another integral, so volume is B minus A, and you know that the volume is area of the base times the height, so here's the area of the base, the height, so this times this. The way they do in the answer key is they just simplify it straight to this, just because these two are the same. If you multiply two of the same things, you just get squared. And that'll get you to here. And like I showed you before, the way you just plug it into your calculator using integrals, and you should get 1.554. 3 decimal places, and yeah, that's how you do parts A, B, and C. If you need additional help solving these problems, I would recommend that you go to chapters 6.1 and 6.2. These problems are very similar to the ones I just did in the FRQ. Particularly, I like number 17, so if you can't see that, it's y equals x squared, comma, x equals y squared, and it's about x equals -1. So in this case, you're finding the volume, which is similar to parts B and C. And again, if you don't know the equations for these, I'd also recommend going back to the notes, section 6.1, 6.2. That problem I would recommend, but if you need a step-by-step way to solving these problems, the notes have solutions, how to solve each one. So, yeah. Thank you for watching.